Greetings and welcome to the second demonstration of the Joe and Mike ET450 Capstone project, our computer-aided test station. Last time we looked at the frequency response of a graphic equalizer. This time we're going to look at the power output of an automotive audio amplifier with both channels driven into a dummy load. We're going to look at that power output as we sweep the DC input voltage. In an automotive environment, an amplifier like that might see anywhere from 10 to 15 volts. So we're going to see what these two channels can produce in power output across that DC range. And we're going to start the program. The program's going to query the instruments, make sure they're powered on, make sure they pass their self-test. And present it with a menu of tests to run. So we're going to run the DC sweep. And this is a Kinter amplifier, so we're going to name the file Kinter. We're going to run it at 1,000 hertz with a 2.5 volt input. And we're going to sweep the voltage from 10 to 15 volts. Because the program is going to compute the output power for us, we need to tell it what the impedance of that load is. It's 4.3 ohms. The computer will now drive the equipment. It's going to hold the amplifier at the beginning voltage, 10 volts, for 5 seconds, let it warm up. Then it will start sweeping the voltage up. As you can see, it's scrolling up in voltage. The oscilloscope is monitoring the output of both channels. And you can see the software has printed the test name with the file name of the test on the screen of the oscilloscope so you can know what test you're running. We're passing through about 12.5 volts, and we see on the computer screen the measured power output of the left channel and right channel. And see, even at 13.4 volts, we're only making 7.6 watts and 7.4 watts. The 500 watt rating of this amplifier notwithstanding. The amplifier is only drawing about 45 watts, so the 500 watt rating might be a little optimistic. As the test concludes at 15 volts, last reading taking, it shuts off the power supply, shuts off the function generator, and we get a test completed message. We'll run the report, which was Kinter. We get a tabulation of the test, and then we can get a plot. The program automatically scales the x-axis to the minimum and maximum voltage we selected, and also automatically scales the y-axis to the minimum and maximum values achieved during the test. And there's the two channels being plotted. It's a pretty good function there. We made almost 8.2 watts. Thank you for watching our video.